Hello everyone. So friends, in our previous lecture, we saw the animation for the top-down approach, that how we can solve the problem related to finding the Fibonacci number using dynamic programming by top-down approach. So in this lecture, we'll code the algorithm to find the nth Fibonacci number using top-down approach. So here in Eclipse, you can see that few lectures back, we saw the bottom-up approach, and this approach is also a method in dynamic programming. So in this lecture, we'll see the top-down approach. So first we'll create a method which will return us back the nth Fibonacci number, which is an integer, and let's say the name of the method is fib. Now as we discussed in our last lecture, that to this fib function, we pass in a memo array which help us in storing the solutions to the sub-problems, and when those sub-problems are encountered again, instead of recalculating it, we just go to this integer array into that particular index, we pick up that value and reuse it. Thus this integer array helps us in optimizing the recursion solutions. So this method also takes the value of n for which we want to find the Fibonacci number. So friends, in order to find the nth Fibonacci number, what we simply do is, we simply first check that whether the memo of n is equal to 0 or not. So what it means that we are using this array to store the Fibonacci series, and as we want to calculate the nth Fibonacci number, we simply check that this array at index n is equal to 0 or not. So if it is equal to 0, we come to know that the nth Fibonacci number has to be calculated. So inside is if condition, we provide a if block where the condition is, if n is less than 2, then what we do is, we simply assign the value of n to the integer array at the index n. So why we do this? Because we know that the first two numbers of Fibonacci series are 0 and 1, and as the array starts from 0th index, so this value will be stored at 0th index and this will be stored at the first index. So we simply check whether n is less than 2 or not. So if value of n is 0, then 0 is stored at 0th index, and if the value of n is 1, then 1 is stored at the first index. And if n is not less than 2, then in the else part what we do is, so here we know that the Fibonacci series has property, the current number is sum of its preceding two numbers. So based on these two properties, what we come to know that if we want to calculate the nth Fibonacci number, we need to know its two preceding numbers, which is n-1 and n-2. We do its sum and we get the current number. So here let's say current number which we want to calculate is nth number. So what we do is, we first calculate the fib of n-1. So we call this fib function recursively, which we also discussed in our previous lecture. So whatever the value it returns, we store in the left. And then we again call the fib, passing in the memo array, and pass in n-2. Because if we want to calculate the nth Fibonacci number, we need to know the n-1th Fibonacci number and n-2th Fibonacci number, And once we know these two values, we can do their sum, which is left plus right. And as we know left plus right, we simply store this value at the nth index, because we know that this integer array basically stores the Fibonacci numbers. And as we want to calculate the nth Fibonacci number, we simply store the left plus right at the index n. And finally, we return the answer, which is the value stored at the nth index. So friends, here you can see that this line is very much important because this line checks that whether the sub problem is solved again or not. So here what we do is, if the mem of n is equal to 0, we come to know that the value at nth index is not been solved. So what we do is, we go into if block and we calculate the value of nth index and we simply store it here. And what if the mem of n is not equal to 0? Then we know that we have already solved this problem. So then we simply return the value stored at nth index. Also friends, in our previous lecture we saw the animation, that how this line helps us in optimizing the recursion, so that we don't have to solve the sub problems again and again. And as we start from the value of n and then we slowly go to the bottom by doing n-1, n-2, and then again recursively moving down. Therefore this approach is also known as top-down approach, because we start from the top and then go to the bottom. And as we go to the bottom, we encounter these base cases where the first two values we store as 0 and 1. And after getting these two values, we build up upon the solution. And finally, we get the nth Fibonacci number. So friends, now let's see the demonstration of this code in the main method. So first we'll initialize the Fibonacci number class. And let's say we want to find the 6th Fibonacci number. So here the value of n would be 6. And as we are calling this fifth function, we need to pass an empty array whose size would be n plus 1, which is 7, because we want to store the Fibonacci numbers from 0 to 6. And finally we need to return the value at index 6. So as we are going from 0 to 6, we need to initialize the array of size 7. So we simply pass an empty array of size 6 plus 1. And if I run this code now, so we get the answer as 8, because here you can see that in the array it will be stored in this format. 0, 1 would be the starting values. Then we do the sum of these two values, we get this value. Then we do sum of 1 plus 1, we get 2. Then 2 plus 1, we get 3. 3 plus 2, we get 5. 5 plus 3, we get 8. So friend, this is how we can use dynamic programming to solve this problem, to find the nth Fibonacci number. And using this top-down approach, we have solved this problem very efficiently. And whatever the solution we get is highly optimized. So friends, I hope you like this video. And in case you have any problem, you can watch my previous lecture where we go through this code step by step using the animation. And in our next lecture, we see different problems associated with the dynamic programming. Thanks, have a nice day.